On your machine learning journey, in order to progress from novice to machine learning god, you first need to master the basics. Kind of like the wax on, wax off moment from Karate Kid. In computer vision, that moment is the ResNet. I'm going to show you why it's so important and how to code it. You remember that classic scene in Karate Kid where Mr. Miyagi teaches Daniel-san some seemingly random chores that turn out to be the building blocks of martial arts? Well, ResNet is your Mr. Miyagi in the world of computer vision. It's not just any neural network, it's the one that'll teach you how to stand tall, even in front of most complex tasks. ResNet stands for residual network. It's all about shortcuts. In traditional neural networks, each layer learns specific representations of features in the data. But as you add more layers, it can become challenging for the network to optimize and learn effectively. ResNet's genius lies in its ability to skip some layers during the training, like stepping over some short stacks of blocks instead of stacking them all together. And the residual connection ensures that the original context is never lost deep into the network, the so-called vanishing gradient problem. This not only makes the training more efficient, but it also counters the vanishing gradient problem. So now that we've talked about it, let's code ResNet, a residual connection layer, in as little as 2 lines of code with pytorch. First of all, we're going to import torch as we usually do, and that's basically going to be the only import. Now we're going to create a very simple pytorch module that includes 2 convolutional layers, batch normalization, and activation layer. Basically a very simple feed-forward network. We're only going to make a couple of very small adjustments to this feed-forward network. One is that the residual connection will pass on the initial data through a skip connection. So assuming the initial data was an image with 3 channels, well, those will be passed on, and we're just going to subtract them from the out channel just to keep our numbers equal. And at the very end of our forward pass, we're just going to concatenate them back as the 3 initial channels, so that the 3 initial channels are always the initial data. And that's pretty much it. This is a residual channel, a skip connection that communicates back the initial data to the network. And the entire network retains context awareness and is aware of the same 3 initial channels that were inputted at the beginning. So with this one simple change, in theory, you can really grow your networks to monstrous sizes. If you like this video, follow along, because the next step will be we'll create ResNet encoder and decoder to make a monster VAE, a variational autoencoder.